All right, we're live. Okay, so let's go over, or do we have any questions? Do we have any questions on lesson four preparation?
I didn't have any problems really with it. I think I was able to get everything pretty close to everything.
Yeah, I didn't have any questions either. Um, did you did you do the part two kind of on your own?
Hmm.
Okay, I did too, and there was one that I had a question on, but I ended up figuring it out, so I'm not too worried.
Okay, awesome.
Okay, so I guess we'll just do the group assignment. Where is that? Okay, starting. Okay, true, true.
Mhm.
Do I need? I don't need to share my screen with you this time, right? You have a computer.
Yeah, I'm able to have a computer with me.
Okay, awesome. I just wanted to make sure that I wasn't just going without you. Okay, so number three, human blood can be classified into one or of our basic types. One of four. I think that's supposed to be four. O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in this following table. Okay. The blood types or proportions given in the table above define a probability distribution. I think that's just if they add up to 100.
They add up to 100.
I well, or to one or whatever. Let's see.
Yeah.
Okay, it adds up to one, so I think it's true.
Okay.
Is that what you had?
No, I didn't do that one because I was
Oh,
unsure.
okay.
I did four through 10. That's what
Okay.
I did.
All right.
Um, beforehand just to like read through and kind of like yeah. So
Okay. Um,
um
go ahead. Do you want to go?
oh yeah, it says what is the probability that a randomly selected person in the United States has type O blood? So I thought that was just like an identification question, unless I'm wrong.
I think it's just 0.45.
That's what I got. So I thought it was just us identifying.
Yeah.
And then
Just point.
I have A positive. What is the probability that it's a randomly selected person will not have it? And then that's all of them added together. So it's 0.55. That's what I
Let me just check.
got.
Okay. I trust you, but I was like, just to make sure. All right. Yeah.
Oh
So
yeah. Oh, definitely always check me because I'm dyslexic.
oh
So
no, you're good.
it might be right in my mind, and
Yeah.
I don't see it.
If it's a quick check.
Yeah.
Okay. And Carolyn Willis and her colleagues tested the study in which dogs were trained to detect bladder. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tingle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine are lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. Answer the following question. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
Is it 1 divided by 7, or is it like 1 divided by 6? Because if it's 1 divided by 7, then I got 0.143.
Uh,
Because it's 1 out of 7 is correct. One out of the 7 is correct. But I
right.
know, but I know one time, like working with probability, like a long time ago, because it's been forever. Like, so I know that there was some kind of rules that are like, no, it's actually 1 out of 6 or something. I don't know if I'm gonna
Yeah.
get confused.
Um, seven bowls containing 6 of the samples did not have, and one did. So yeah, I think it's what is the probability that they correct I think it's 1 divided by 7. Is
which
that
is,
right?
yeah, and then just double check me on my math, but I think it's 0.143.
Yeah, yeah. 0.143. Bless you.
Thank you.
In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random choice alone. Which of the following statements is most appropriate? This provides strong evidence that the dogs can detect bladder. There is little evidence.
I put that there was little evidence because it's not. Yeah, it's unlikely that he would do this well by random chance alone.
Right.
But it doesn't. But that's still not enough evidence. So that was my guess. But I don't know. I'll go with whatever you want to put because I was just guessing. I was just.
Right. I don't. Let me read it again. I think that there's little evidence. I mean, it is about. No, it's not quite half, but I don't know.
Like, yeah, sometimes like so the dog is defying the odds, but it's not it's just not enough evidence.
Yeah. Okay, let's say that. Go with
I
that.
don't know. I don't know. That's what I would like guess. Like if I was like I don't know. That's what I would say like with like, if it was actually happening.
Okay, that works.
I'd be like I'm like that's pretty awesome, but that doesn't prove anything. That's what I would.
Yeah.
Yeah,
Where's the evidence?
exactly.
Okay. M&Ms are small chocolate candies. What? Um, the M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of M&Ms, what is the probability of trying out a red candy? Well, isn't that 0.13?
Yeah, that's what I put.
Okay.
And then for green, it's point 16 because all of them together is 0.84. But check my math. So that's so number 9, I got 0.16, and then 10, I got 0.48.
I got 0.85 for the total. Let me see.
Because it's 13 plus 14 plus 13 plus 24 plus 20.
Oh, what am I doing? Hang on. 0.13. Oh, that's what I did.
You got a 0.5 out of
Okay, I got 84. You're right. So then 1 minus 0.84. 0.16, what you had?
And so that means number 9 is the 0.6, and that the us adding it up actually answers the question to number 10, which is not the green candy.
0.84. That's what.
Yes, ma'am.
Cool. Okay. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from Capex.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number?
See, I didn't get that one. That's where I stopped, and then one of my friends brought me food, so I was like, oh, I got distracted, and then I was just, yeah, I never got back to it, so I'm just like, wait a second, because I'm still having trouble with the definitions of like, I always get mean and median mixed up and stuff, so, and yeah.
That question doesn't even make sense. Half of the observations are less than or equal to what number?
So what number is it?
You might have to ask Jared about that one because I have no idea what that one's asking.
I guess like if all the things was like 1, 2, 3, 4, 5, like if it was 1 through 10, then it'd be equal to half of them would be equal to or less than 5.
Right.
if like all the numbers were one, yeah. But
So
that's still really hard because I'm just like, I don't know what it means with all these different random numbers.
yeah, because it's not like it's not just.
Yeah.
I mean, the median is the middle number. We don't know if there's more 24s. It's not like let's see. Based on the table above, the top 25% of the students scored above what number?
The
Uh,
25% is that Q3?
the top 25. I think so. Yeah, because the median
I
is
have no clue.
2. The quartile 3 is the top 25, I believe. So they scored above 27.
Yeah.
That makes
That's what I would guess.
much sense. Okay, which of the following statements is not one of the rules of probability? Rules of probability. Okay, so these are the rules. The probability of an event X is a number between 0 and 1. If and then the second one is if you list all of the outcomes of an experiment, such as rolling a die, the probability that one of these outcomes will occur is 1. In other words, the sum of the probabilities of all the possible outcomes of any experiment is 1. And then rule number 3 is the probability of an event X, an event X will not occur is 1 minus the probability that it will occur. So it's not the first one. It's not the second one.
So the one
I think it's the
is
last one. Oh, no, you're right. Okay, yeah.
if the yeah,
It's the third one, yeah, because the second rule is the
yeah. Okay.
so we
And
need
then
11.
so we all we need is 11. Let's see. I would be guessing then on the median, would that be 24? No, wait. Oh no, it could be the average. Where's the average? Average is the
The
huh.
mean is the average. So half
So,
are less than or equal to.
so would it be the mean?
I don't know, because that's like the average. It's not. I don't know if that's.
I'm gonna try to look it up. Okay, it says half of the observations are less than or equal to what number? Would that be the mean, the standard deviation, the variance, the median? What would it be?
Jared.
The mean is average.
Yeah, but would that be the observation, like half of the observations are less than or equal to the mean?
My brain doesn't want to work right now.
Trying to he's like he goes my brain doesn't want to work right now. No, he works for Bank of America, so that's why I was just like,
He uses his brain all day.
yeah.
I know what mean. At least I used to know what they mean.
Yeah, so I was asking him because I'm like, well, you deal with numbers all day, don't you? That's the problem.
Jared.
I just get it. No.
He's ignoring me. I'm gonna text. Okay, that's done. That's the only one we need.
I'll try to look it up. Okay, I think it's saying, let's see. Okay, I'm looking up a definition for median, and it says use the median to describe an entire set of observations with a single value representation, the center of the data. Half of the observations are above the median, half are below it. Then it'd be median, not mean.
Yeah.
So the median is
I guess that kind of makes sense though, because if it's like a whole list from what, 27 is the highest? No, 35. From 35 to 0 to 35, and then the median they say is 24. That means that at least half of the people got a 35 or lower, right? Because
yeah.
or 25, 24, sorry, 24 or lower. Because if the median was 25, that would be the middle number. Then we would say 25. I don't know.
Yeah, it would be. Yeah, that makes the most sense. Here, I'll submit it first and then we'll see.
Okay.
Hey, I stopped caring about my grades a long time ago, and like as long as we're
Sounds
putting our best foot forward, I don't mind submitting it at all.
good. All right, I'm
So,
gonna stop recording. This is our meeting. Woohoo!